And I think we are live. Let's see where we're at. And hold it. We got Instagram, we got Facebook, it looks like. It looks like we're live on everybody. Hello, good evening, everyone. Welcome to another week of live chat with your meteorologist, Stephen DiMartino. We have a couple things that we're going to be covering this week. Of course, we're going to talk about the development of La Nina and how that's evolving, the weather pattern overall, the severe weather that has been dominating the plains as expected, unfortunately. We talked about this all the way back in, well, heck, late February, that there would be some concerns about some pretty impressive severe weather, and unfortunately we've seen that so far. We've also seen an evolution of our weather pattern remaining unsettled, but not a lot of rainfall of late. It's kind of been hit and miss, which can be a real pain if you're trying to work outside and trying to make plans, because some locations have heavy rainfall, other locations don't. So it could be a bit of an issue. So with that, let's dive into some of the data. And of course, as always, I'll go back and answer all of your questions. I have a nice little setup here going over everything. And of course, my wife will be helping with the social media, and I will answer all the questions on the live chat, as always, in the premium section, and then pick the best questions out of social media land, which I have to admit have been getting progressively better. They've been getting very interesting. I'm very happy to see a lot of these great questions that we get from the general public with the interest in science and whatnot. It used to be back in the days you get all like these conspiracy theories, which is always fun to discuss, mostly because I find it more ingenious of how some people put all these things together and kind of twist reality in a way. It's very interesting. I find it. I think they should be fiction writers. I really do, because they make great books. But let's take a look at the observation. So we're going to continue to keep an eye on the sea surface temperatures to see how they continue to evolve as we move through spring and into summer, and of course early fall, especially with all the concern about the tropical Atlantic and the potential for activity. Not much has changed in terms of the Atlantic. Still a lot of concern here because of the very warm sea surface temperatures that we have in place. Again, the one caveat that I see that could limit this hurricane season is the dust that will linger off of the Sahara Desert into the Atlantic Ocean. That's going to be a bit of a wild card. But other than that, if that dissipates, and there's pretty good data to suggest it would by the time we get to late July and August, it's pretty much open season. You got light shear, plenty of warm water. The only question is, how do the warm core low pressure systems evolve and organize? And when you also see this signal here with this cold pool and the warm here, this is a textbook positive AMO signal here. That supports high pressure systems to build and send tropical systems at the very least towards the Caribbean. And then you watch out for the Gulf of Mexico and the East Coast and so on and so forth. So concerning signals here, and you know me, if you're new, then you'll get to know me, that I do not like to hype. I do not like to go around saying, oh my God, the world's going to end and all that garbage. If you want that, you can follow like a billion different storm chaser guys out there saying the world's going to end. But here, I'm just going to tell you the bare bone facts. And the bare bone facts are this. That amount of warm water is like nitroglycerin, okay? You have that type of warm water in place now before we even reach the peak season. You're going to have a lot of fuel for these storms to feed on. And if you get favorable conditions, which it looks like we will, that can lead to a lot of issues. So I continue to repeat this. If you saw this last week, you're probably saying to yourself, I've heard this already. Yes, and you'll hear it again, because I want to make it very clear. Prepare now. Let other people panic and panic buy and lose their mind. Prepare now so that way you don't panic later, right? Meanwhile, in the Pacific, our La Nina is developing. But we still got a pushback of El Nino as well. El Nino is not just going to die. It's still trying to fight back. Okay, it's still trying to linger. Okay, it's going to die. It's on the way to dying. It's lost its subsurface support. It's losing its atmospheric support. La Nina is coming on. You can see it in the eastern regions very nicely here. The cold water is very nicely organizing here. But we won't see the pure La Nina influences until we get to the summer period. And I'm thinking more like mid-June at this point. We're seeing the changes in the sea surface temperatures now, which was expected and evolving rather rapidly. But in terms of the atmospheric influences, the weakening of the subtropical jet stream, for example, probably not until June. Meanwhile, the northern Pacific continues to remain cool. This is really important, this signal here. This signal is more important to me than this signal. You might be saying, why? I hear everything about La Nina and El Nino. You would think, the way that some people talk, that El Nino and La Nina are the only factors that determine our weather pattern. They do not. El Nino and La Nina are very important. And this La Nina will be very important. A lot of data points to this being more of a weak, maybe moderate La Nina. Anyone running around calling this a super La Nina either is not looking at the data or trying to scare you. There is literally no data, zero reliable data to call this a super La Nina. You have a few outliers which you would expect in any global model guidance, but the majority, the average is suggesting anywhere between Nino 3.4, which is this region right around here, bouncing somewhere between minus 0.6 to minus 1, which is, again, in the weak to moderate range. So we don't see any data for a super La Nina, and quite frankly, we don't see any atmospheric or observational support for that, okay? But the reason why the PDO stands out to me far more important is that this is an enhancer, okay? This will help to enhance our transition towards La Nina. When you get this negative PDO signal, you support the potential for more of a trough in the Gulf of Alaska into the west coast. And you increase the potential for above normal heights in the southeast. So when you get a La Nina starting to develop with this signal here, you enhance the signals once you get into the summer and the fall seasons. So in terms of tropical forcing, that is going to help me understand, okay, yes, it's a weak La Nina. With the negative PDO signal, I'm going to lean more towards an east-based La Nina in that respect. As we get going, I'm going to keep an eye on the observation to see if that actually bears fruit. Sometimes it shifts more towards central, sometimes east, but one thing's for sure, the coldest waters typically do not end up in this region. They usually end up somewhere in here, which means that your tropical convection that we always keep an eye on, because that's very important, because the release of latent heat enhances your subtropical jet stream. Well, that looks like you're going to still see some convection right around the date line and then on westward. So that would support a subtropical jet stream with some short waves, with some influence. It won't be completely dead, and the polar jet stream won't be able to completely overwhelm it. But I'm kind of getting ahead of myself in terms of the evolution of this pattern. A lot of interesting data really to dive into. So again, negative PDO signal, perfect. La Nina is developing, positive AMO signal, trouble possibly from the tropics, prepare now. Then you get some of the observations that help you determine where we're at in this whole transition. Because right now, that's where we're at. That's why we're seeing all this funky weather going on right now, with warm fronts stalling out and severe weather in the plains and low pressure systems approaching, producing showers and unsettled conditions. A lot of competing factors, and one factor that must be extremely annoying to winter weather lovers is a persistent negative NAO value now. I know, I already got hate mail about it, like as if I control these things. But we've seen a persistent negative NAO pattern. Why are we seeing this? Well, let's take a look at some of the forcing mechanisms here. This right here is the SOI. Now, some of you who have been following me for a long time know I use this to understand where we are in terms of the atmospheric response to El Nino and La Nina. When you have a negative state, the atmospheric response is more El Nino-ish. When you have a positive state, it's more La Nina-ish. So what you do with the daily contributions here, this helps you determine the trend and the potential for significant storms. So when you go like in this negative area here that we see this trend right down here, that typically points me to a higher potential for storms in the eastern United States, more East Coast cyclogenesis. When I see positive values, it leans more towards a storm track towards the Great Lakes, which is exactly what we've been seeing. Meanwhile, the overall trend is slowly heading towards La Nina. Why is that important? It tells me that the transition and the evolution of the subtropical jet stream is taking its sweet time organizing. And because of that signal, it tells me we're going to continue to get a mixed bag of forcing mechanisms driving this weather pattern, which means that I need to go to another forcing mechanism to study and understand how to forecast for this weather pattern. And that takes us to the good old MJO. The MJO it's a speedboat in terms of wave influence against the Titanic. Okay? So the Titanic is your El Ninos, your La Ninas, your negative PDO signals, all that stuff in terms of wavelengths in the atmosphere. The MJO is that speedboat flying by it, that when it aligns just right, it can enhance the weather pattern. And when it doesn't, it kind of degrades it and creates a lot of mixed noise. Right now, the MJO is in phase 3, 4, and 5 for the most part. There's some days where it tries to jump to 6, and some model guidance tries to push it. Let's say the GFS here tries to shove the MJO towards phase 6 here. CFS kills it and then tries to bring it back into phase 4 and 5. So what you want to do with this data, you never take this verbatim. A lot of people take it verbatim. What you want to do is just take the trend. Take the trend of this overall theme, right? And so what we have with this trend here is that it's a weak MJO signal in phases 3, 4, and 5 during a transitioning La Nina period, which would suggest a very active storm track cutting towards the mid-Atlantic and Great Lakes, depending on other forcing mechanisms. We say, what other forcing mechanisms? Well, you think it's just one and done. No. Let's talk about the stratosphere. Now you might be saying, Stephen, the stratosphere, it's spring. Yes, it is. But changes are occurring here too. You see, this is called the QBO. Now, most of the time, we study this quite a bit more in the winter, especially with our winter forecast that we start to organize. It's on the way moving from a negative state to a positive state. Negative in terms of easterly, positive in terms of westerly. Why is this important? When the QBO is negative, easterly winds, it's pushing against the rotation of the Earth. So it has, and again, this isn't like incredibly strong. We're talking about meters per second, okay? But that small meters per second influence has a impact in the way and potential in which the polar vortex weakens, and you increase the potential for high latitude blocking. And of course, in the winter, stratospheric warming. But I digress. When it goes into positive state, it's going with the circulation, enhancing the circulation of the weather pattern. So your angular momentum in the atmosphere speeds up. It goes into a positive state. The movement of the polar jet stream speeds up. It goes into a faster state. With all of this occurring, what are we seeing right now? Transition. This is the fourth forcing mechanism that we are watching where we're in a state of transition. Now, right now, in the area where it matters, 30 to 50 millibars, we're in this easterly state, but we're in the process of changing to a westerly state. So the easterly state still supports the potential for some mid to high latitude blocking, but it's on its last legs. It's getting ready to collapse. But before it does that, it's not going to go out without a fight. And that's why we've been seeing this negative NAO signal combined with our cold sea surface temperatures here. So you're getting this gradient that's setting up here. This is a Gulf Stream. You got this feature right here, cold water. You have your warm water right around Labrador. So you're getting this clash of thermal gradients combined with what's happening in the stratosphere. You want to add one more thing? Let's add one more thing. Because why not, right? Stratospheric temperature anomalies. So what? You just thought we just looked at models and copy and paste? No. This right here gives me an idea of what's going on in terms of the vertical transport in the atmosphere. And not a lot of people talk about this, and it's something that you're probably not going to hear on the news and whatnot, because it kind of gets really, really, really techy, right? But here's the basic idea, and some of you guys who have been following me for quite some time, you know where I'm going here. The warm anomaly pockets that we constantly see, it allows for a compression in the troposphere. Why? When you're warming in the stratosphere, right, it can't expand out into space. Like the atmosphere cannot expand further out into space. So when you have warming columns in the stratosphere, it presses down on the troposphere. So when you're pressing down on the troposphere, it creates below normal heights and a higher potential for upper level lows. Now look at where we keep on seeing these warm anomalies popping up. Not consistently, they waver back and forth, but as you can see, they continuously show up around the northern tier. You also see them around the west coast, and it's a factor that works back and forth in itself because the atmosphere doesn't just stay in a stagnant state. It's constantly looking for that balance both vertically and horizontally. That is what we're talking about here, a vertical and horizontal balance sheet. So while it's dealing with this balance sheet, it increases the potential for your below normal heights around the northwestern Atlantic. This is something I'm going to be watching all through the summer. It has me concerned when we're looking at an active hurricane season potential and those anomalies here, because it increases the potential for a block setting up. As the QBO is changing, I think that this block support is going to start to fade. But it's a little bit too close to call, in my opinion. And it's something that we really need to watch out for the East Coast. In terms of not just direct hit to tropical systems. I know that's what you're thinking. I'm not talking about Sandy type things here. What I'm worried about is that you get a tropical low pressure system with remnant rainfall hanging around the region in the late summer and early fall with that signal. So that is something we're going to be watching out for very, very carefully. Now we have all those factors together. Let's take a look at what it's doing to our atmosphere right now. This is from Earth.NewsSchool. It's totally free website. Check it out if you haven't seen it already. And by the way, all the data I have here is all from NOAA so far. So we literally paid for it with our taxes. So it's free. So everything that I talked about is showing up here very nicely. Here is our developing influence of La Nina and our negative PDO influence with our ridge trying to build. But again, because it's competing with all these other factors and the lingering influence of El Nino, it's not blowing through. It's not dominating. It's instead taking its time to organize. While that's happening, notice the subtropical jet stream remains active. Very strong here in the plains. Why have we been seeing all this vertical shear? Why have we been seeing all these tornadoes? Because you have two competing jet streaks in the middle of the country while you have tropical air trying to surge northward, polar air trying to drop southward. You add these ingredients together with moisture transport from the Gulf of Mexico, you're going to get some impressive thunderstorms. And we continue to see that theme. Meanwhile, you continue to see, because of those warm pockets we're showing in the stratosphere, the below normal heights around the Canadian Maritimes, which as this wavers back and forth between, let's say, the Gulf of Maine and the Canadian Maritimes and the eastern coast, the Atlantic coast of Newfoundland, as it wavers back and forth, that's where we're going to see our wavering backdoor cold front and those pushes of maritime air, tropical air, maritime air, tropical air. If you're in Long Island, you've experienced spring and summer literally on the same day. It's even worse if you go from Philadelphia to Long Island. Philadelphia's 85, Long Island 65. Yikes. That's going to continue to be a theme, at least through much of this month and possibly into June, where we continue to see this wavering back and forth until we lose the forcing mechanisms. In terms of support for severe weather around here, I don't see it yet. But that doesn't mean it won't change. You see, if we continue to see this below normal height signal in the Canadian Maritimes, and you start allowing for this ridge to build, what you're going to end up with is a scenario where you're going to get some very hot and humid weather conditions pushing up towards the Delaware River Valley, Poconos, Catskills, New York City Metro. And you're going to get these pesky short waves trying to move around the ridge, enhanced with a stronger polar gesturing because we're moving into La Nina. We're moving into a positive QBO state. Don't be surprised and watch out for very strong thunderstorms as we move into the summer, diving in from the Great Lakes and heading towards our neck of the woods. And it could be a very stormy summer for locations like the Poconos, like the Catskills, northwestern New Jersey, and also a very frustrating one if you're interested in thunderstorms along the immediate coast, because usually this type of pattern, because you have storms downsloping off the Appalachian Mountains, this type of pattern leads to thunderstorms that weaken as they head towards the coast and cross into the Delaware River Valley. But that's something that I'm keenly keeping an eye on. The other factor that I'm very much keeping an eye on is the location of this ridge axis as we move into the summer. With all these competing factors, I certainly could see the ridge axis kind of getting spread like this, shooting from the Gulf of Mexico up towards the coast of North Carolina like this. And if that's the case, then you're going to have a lot of tropical systems cut into the Gulf of Mexico and then wrap themselves right around that ridge and shoot right up into the Ohio River Valley and eventually the northern mid-Atlantic as remnant rainstorms. That's something that we're definitely going to have to watch out for. But in the meantime, we're going to continue to deal with this theme of maritime and Pacific and tropical air masses clashing against each other. Over the next 10 days, we continue to see that theme. Towards the end of the 10-day period, I wanted to show this on the European and the GFS. Notice the difference here, right? And then we go to the ensemble guidance. Ensemble guidance on the European is not as strong as the operational. I think this is overdone on the operational. So how would I know that? Well, for one, it doesn't have the strongest support in the ensembles. It pulls it further north, suggests more of a deeper upper level low up here. When you have this split here, usually this means that there's a lot of volatility involved, so you should really start to question it. And then, of course, the Canadian and the GFS, if you kind of mix them, then you kind of end up with this signal here rather than this signal here. But also, the other factor is that it really doesn't move with the observations that we all just talked about. So more likely, more of a progressive system. The upper level low is probably more to the north of the Great Lakes. It also opens up the potential of severe weather being a threat with this system more towards the Ohio River Valley and heading up towards the eastern Great Lakes, and then the northern Mid-Atlantic dealing with a lot of showers with a triple point type of low pressure system. But the overall theme with this pattern is that as we go through the next 15 days, it continues to be the same theme. You continue to see below normal heights ending up towards the Canadian Maritimes. Your ridge continues to try to fight back. It gets knocked down, returns again. Your trough in the west keeps on trying to come back. Again, this whole pattern evolution is under the influence of competing features that we all just went over, right? So as long as we have these competing features, two themes are going to remain in place here. One, model volatility is going to be insane, unfortunately. It's just not fun for me. And number two, we're going to continue to remain in a very active pattern. I foresee a lot of severe weather continuing in the plains, in the upper Midwest, in the Mississippi River Valley, and heading towards the Ohio River Valley. I think for us, we continue to deal with a lot of these hit and miss shower events that can be rather annoying, but I don't really see right now a widespread heavy rainfall event. Anytime you've seen a heavy rainfall event advertised 7 days out or 5 days out in the mild guidance lately, it kind of peters out to just basically scattered showers and nowhere near as significant as some of the guidance suggested. So where we are right now, well, we have a lot of severe weather going out here in the plains. This is, of course, from WeatherTap with our surface. We got tornado warnings all up and down heading into the mid-Mississippi River Valley. Again, you got your clash of air masses here. Your tropical air mass surging northward, Pacific polar air mass trying to press southward. Here's your maritime air mass trying to press southward with plenty of rainfall up here in New England. What does this look like in terms of precipitable water value? Well, here is the forecast at 0Z, which is right about now. And what you have is a textbook example of three air masses clashing against each other, which is supporting all this severe weather. You got your moisture transport, and guess what? This signal, let me zoom in here for you. This signal is going to remain the same signal. You're going to see this again and again and again for at least the next 8 weeks. And you're going to see a continuation of more support of severe weather, unfortunately, in the plains with this type of signal. This is not ending anytime soon. And this is a typical signal from a negative PDL aspect. And then as La Nina gets more and more organized and stronger, you're going to see more of an influence from that. Let me see the latest. Okay, you might be wondering why this is 27 degrees. This, unfortunately, is in Celsius from the Aviation Weather Center. This is aviationweather.gov. Normally, it's in Fahrenheit. They're having some data issues, unfortunately. But it also gives you a chance to know what Celsius is when you have temperatures in the upper 70s. It means you're in the upper 20s. So if you ever wondered what the heck they mean when you're watching, let's say, a Canadian program, they're saying mid to upper 20s and it's going to be really nice. That means mid to upper 80s. So, I mean, mid to upper 70s throughout the region. So that's what we're seeing here right now. But what I wanted to point out is the southwesterly winds that are in place. Notice the westerly winds out here towards the central Pennsylvania as this cold front drops through back here. Now, why aren't we seeing any thunderstorms with this cold front moving through? Well, the reason why really comes back down to the dry air. We have a lot of dry air here at the lower and mid levels of the atmosphere. It pretty much killed any potential for thunderstorm development. So that's why we're not really seeing all that much in terms of development around the region. And you can see we really didn't have any chance of developing much of a cumulus. And you can see all your strongest lifting right now is pretty much focused off to our south, not much here around our neck of the woods. So for tonight, we're just pretty much dealing with a lot of sky cloud cover. And unfortunately, back here is where we're seeing our severe weather. Now, all this is going to be lifting northward towards us for tomorrow as this feature here lifts towards the northeast. So I know everyone's wondering about Mother's Day, so let's just walk through that real fast. So we have our warm front that tries to push through. Again, notice the theme here. Ridge trying to build here along the Gulf Coast. Trough here over the Canadian Maritimes. We're caught in between. So anytime a strong short wave approaches, it gets crushed between the two features. Miners out. And that's why we continue to see these impressive severe thunderstorm events in the Tennessee River Valley, Ohio River Valley, the upper Midwest, get torn apart and sheared apart by the time they get here because of this confluent pattern that sets in. By the time we get to the weekend, we have these weaker short waves moving through, but I don't see there being much in the support of heavy rainfall, but just a lot of scattered showers hanging around for Mother's Day, based on these lifting parameters. I also don't see much in the way of severe thunderstorms If you're down towards Cape May tomorrow, you might get an isolated severe thunderstorm. But I'm not really seeing a lot of strong support for it. Take a look at the Cape forecast for tomorrow. A lot of this is suppressed to the south here. When you're below 100 joules per kilogram in the forecast, it doesn't really support much in the way of severe thunderstorms. You usually want to be around 1,000 joules per kilogram or above, all right? You could get some of those mid and upper level winds mixed down in some of these showers and thunderstorms, and so that is what's showing up here in some of the mesoscale guidance. So we got scattered showers throughout much of the day. In the mesoscale guidance and the HRR guidance, you could see some of those thunderstorms showing up on the NAM and on the HRR. But what kind of stands out to me is that you got a lot of stratiform precipitation up here, and you don't have a lot of clearing taking place during this time period when these thunderstorms are organizing. So I'm not all that impressed with what I'm seeing here for southern New Jersey. I do think you'll probably get a couple of rumbles of thunder, heavier downpours. Tomorrow's actually going to feature the most rainfall you're going to see around the region, and that'll continue on into Friday. And then for the weekend, again, kind of broken up. It's pesky showers. It's not going to be a dry Mother's Day weekend, unfortunately, but it won't be a washout either. So with that, I pretty much went over everything I wanted to go over. Now I will take your questions, and we'll start off first with the premium live chat as always. And Card is off and running already with a really good question. Saw the QBO write-up this evening. If I recall correctly, the strength of the QBO is also a factor in blocking. Yes, it certainly is. A weak QBO is not favorable for blocking, but it doesn't have a big impact on as a stronger one. Any data yet expected in terms of the strength of the QBO? The way that I usually like to study this is to see what we're dealing with at 10 millibars and 1 millibars. Because what happens is that the QBO phases, they drop from the higher portions of the atmosphere, let's say the higher portions of the stratosphere, down towards the troposphere. What they're looking like right now is moderate to weak. I'm not seeing anything that's overly strong yet. That can easily change, though, as we get closer towards the fall season. This is something I like to measure when we get towards September and October. I start to dive in more into the actual strength that we're dealing with. Right now, what I'm more concerned about is the orientation, because in the summer, that's going to tell me just how long that high latitude blocking signal is going to remain a threat. And good evening as well. Card, let's see here. I guess the Knicks are playing. I don't know. Are they winning? I have no idea. Nice line of thunderstorms this morning. Yes, absolutely. With the warm front, with isotropic lifting. Solar note from Card. Sunspot AR3554 is now the size of the Carlington spot. That's a big one. For those of you who don't know, that's one of the bigger spots. It is big, unstable spot facing towards Earth. Potential for a strong Quebec to Carrington level event exists. Maybe. I did read the same thing from spaceweather.com. If you've never been there, definitely check it out. Great source of information, great data to study. I'm always very careful with that because having that type of solar event impact our planet now would likely be devastating. Not from the Earth blowing up or any of that nonsense from Sci-Fi Channel. Think about all the things that were connected as far as electronically. I mean, just getting your paycheck now is not even like a paper paycheck. It's all digital, right? So if you had like a massive outage from that, power outage and just shorting everything out and shorting out satellites, it wouldn't be fun. I'll put it that way. That is for sure. So let's hope it doesn't get anywhere near that. Looks like some big temperature contrasts in the Indian Ocean with cool pool to the southwest of a larger warm pool. Let me go and see and pull up that data here. Okay. Where are you now? Let's see here. In the Indian Ocean. You mean down by Madagascar? It's got to be down by Madagascar. Da, da, da. Well, this right here, I mean, you're getting pretty close. Understand when you're getting down here, this is like winter. This is like starting to be like winter down here. So you would expect to see some pretty significant cold pools starting to show up down to the south of Madagascar. So nothing really is showing up that's significant. If anything, we're seeing a lot above normal temperatures, aside from what you would expect as you head towards winter down there. Well, the Titanic. I mean, but everyone understands what the Titanic is. That's why I used the reference. Let's see. Do we have any questions here on YouTube tonight? No, we're pretty quiet. How are we doing on X?
Quiet.
Quiet. You know what it is because everyone's watching sports. I know that is a fact right now. I don't blame people. I mean, look, the Knicks are playing, I think. The Rangers won, I think. The Yankees are on. What are they? I think they're on Apple or no. They're on something. They're not on TV though. I forgot what they're on. Oh, Amazon. That's right. Yeah. Every time on Amazon, it's not good. Everyone always gets annoyed with that. So with that, let's see if we got any interesting observations. I'm going to zoom in on our thunderstorms here. Very impressive setup here going on with our severe thunderstorms. Look at this line here. That is scary. I don't mean to get off on a rant here, but it's what I do anyway, so what the hell. I, for the life of me, do not understand some people running around saying, like, if they don't get a tornado, it's some sort of bust, like it's some sort of thing to be disappointed. If you want your house destroyed, by all means, destroy your own house, okay? But to root for these type of events and to be disappointed if they don't happen in your backyard is insane. That's the best way. There's something wrong with you. Okay, these storms right now, they have the potential to injure, kill, destroy someone's property, someone's house, a house that maybe someone saved all their lifetime, their life savings for, and you're disappointed that you don't have an F5 or an F4 tornado. Are you serious? Get a grip, dude. What's wrong with you? No one wants to see these storms. And if you want to see these storms, I don't know what to tell you. Hopefully, they never impact you. I mean, I understand seeing them like in the plains, like in let's say in western Kansas, you don't have too many houses, and they're out in a field. I get it. Majestic, blah, blah, blah. Watch out for the cows that are flying. I get it. But when you're in major metropolitan areas, like what we have here, this is just terrifying. I mean, the biggest terrifying factor of these tornadoes and of these severe thunderstorms is that they move through major metropolitan areas during this time of the evening and at night, especially in overnight hours, because it's very hard as a meteorologist, especially as a broadcast meteorologist, to warn people. The National Weather Service, one of the biggest fears is that this happens and people aren't able to be warned because they turn off their phones and whatnot, and you're not able to be prepared. Now, when you're living out in this part of the country here with these type of storms, you typically are used to them, so you prepare yourself. But for some of you guys watching out east, which is most of us on this channel, this is absolutely terrifying. And take it for someone who's lived out there. There's nothing fun about this because you don't know whether that freight train, it literally sounds like a freight train bearing down your house, is going to destroy your home, possibly end your life. It's not fun. There's nothing exciting or exhilarating about that. When we take a look at this, let me pause this real fast. One of the things that we watch when we keep an eye on these thunderstorms is that you see how we have kind of like these S signals here. And I'll tell you what, let me take off the warnings for a second. Okay. And I'm going to hit play again. Now, what's happening here is that you're getting stronger winds. You're kind of getting this bow signal here, and you're getting kind of a bow signal here. What's happening is that you have different mesolows to the north and south of here. And as you get these mesolows to form, they enhance lifting and they support the development of tornadoes. Now, sometimes you'll get thunderstorms where literally it looks like its own mini cold front, and you have a circulation in the back. In this scenario, you get a squall line, and because of the strong straight line winds, it creates enough vertical shear that causes turning in the atmosphere, and you get these little mesoscale low pressure systems causing this bowing out. And so while you're having this bowing out, you're having very strong winds sinking down towards the surface, creating sinking air and updraft at the same time. The updraft enhances the potential for large hail, so you have that factor. Of course, with all of the latent heat release, you got significant electrical discharge. There's your lightning, and then of course you got your vertical wind shear creating your tornado potential. And so you typically see it here on the north end of these bow echoes that show up here, and that's essentially what we're seeing here. Now, let's see if we can find. Now, down here, here's another storm to keep an eye on for tornado potential. Let's see, right here, these are what you call singular cells, okay? Now, they can become supercells as they grow in size. And what you typically want to watch out for in terms of tornado development is the back end right here. When you start to get this notch showing up here, that means that your mesoscale low is starting to form. And this is when you want to take a look at the wind vectors and see whether or not you're getting in that circulation, starting to organize. Sometimes they don't mature and you just got a very strong, severe thunderstorm. But this type of signal here is something I'd keep an eye out for those mesoscale low pressure systems and those supercell thunderstorms, especially the ones that we saw last night and that we've been seeing in the plains for quite some time. Let's see if we got some other cells here. And again, this is all happening along and to the south of our warm front, in our warm sector, in our tropical sector. Now, when you have this signal here, you typically don't get tornadoes out of this. You have a formation setting up more of the warm air trying to push over a boundary. You got some moisture boundary here. This type of training event sets up more for flash flooding than it would for severe thunderstorms. So when I'm studying this here, I mean, you can still get severe thunderstorms, but more so than tornadoes. I misspoke there. Not so much tornadoes, but certainly severe thunderstorms, flash flooding because of the heavy rain with the continuous training taking place here. And then back here again, this is where you open up your potential for severe thunderstorms, large hail, and of course that tornado factor as well that you have to keep an eye on. And this just goes all the way south. And where you want to keep an eye out again in these signals, in these type of storms for your tornado potential. Let's see if we load it. Trying to load all the data. Here we are. Take a look at this. Where do you want? Where would you be concerned about your tornado potential? Up here is going to be your hail shaft. You're going to have your very heavy rainfall here, flash flooding, lightning, blah blah blah. Down here is where you have your tornado potential. Right here. Okay, this is where you're going to get your mesoscale low and your potential for a lot of vertical wind shear. Down here as well, right towards the end of this. So again, this is where you're going to get your circulation of rising air. Here is where you're going to start to get your setup right towards the tail end of these storms. So that's typically what you want to look for when you're studying this. And so yeah, it's pretty impressive storm event setting up here. Unfortunately. But by us, we're pretty much quiet. Except if you're out towards Connecticut, you're getting some strong thunderstorms moving through northeastern Connecticut. Nothing really severe, though. Nothing that is warranted for impressive thunderstorms Out towards the Cape, though, you're seeing some severe thunderstorms showing up here. But this is all getting cleared out, and the rest of the evening looks pretty quiet. Let's take a look to see if we have any more questions. And it looks like we're pretty quiet here. Let me just reset this here, make sure this is all working out. All right. So with that, I don't think I'm getting any other questions. Anything on X?
Nope.
Okay, so I think that'll be it for tonight. We pretty much went over everything, answered all the questions, and we went over some of the severe thunderstorms. So we'll continue to keep an eye on the evolution of this weather pattern. As we move towards Mother's Day, I'll have additional updates to see exactly what we're dealing with in terms of weather impacts. If you have any outdoor plans, my suggestion is to keep your plans, but have a backup plan, i.e. an umbrella, whatnot. And if possible, just stay indoors. That's it for tonight. Have a wonderful night. Have a wonderful weekend. And as always, stay safe out there.